Class AB, class A, it is operating for 360-degree. In class B, it is operating only for 180-degree. In class AB means it is between the two. So in class AB means the output signal exists between 180 and 360 of the input AC signal. Okay, the output is not full, the output is not half, it is between half and full. So it is between 180 and 360 of the input AC signal. So class A is 100 percentage, class B is 50 percentage of the time the transistor is on. Class AB means it is between 50 and 100. You can choose the operating point in such a way that the transistor is going to conduct between 50% and 100% of the time duration. And in class C, it is going to be half of class B. So in class B, it is going to conduct for one half cycle of 180 degrees of the input AC signal, right? So class C, it is going to be less than 180. So already in negative half cycle, no amplification. Even in positive half cycle, it is going to be less than 180. You can see the waveform is not exactly starting at 0. It is starting after some time and it is ending immediately before 180. So the conduction is going to be less than 180 degree or less than one half cycle of the input signal. That is going to be for class C amplifier. So 4 amplifiers we have seen: class A, class B, class A, B, and C, and we are just classifying them based on two parameters. One is how much time the transistor is on, okay, and second thing is based on efficiency. So how the efficiency is improving from class A to class B, class B to class AB, and class AB to class C, and non-linearity is reducing as we move from class A to class C. So these things you have to be very, very clear. There is nothing to confuse here. Everything depends on where your transistor is operating.